So, we are smack in the middle of an AI revolution. I mean, the models are getting smarter, the industry is just exploding. But there's a catch, a very real physical limit that could seriously slow the whole thing down. Our power grid. It's this incredible clash, the speed of digital innovation versus the slow, deliberate pace of building stuff in the real world. Okay, let's really break down this growing energy problem. Right, here's the absolute core of the issue. You've got our existing power grid, something built out over decades. Now, just drop the AI boom right on top of it. These data centers are just popping up everywhere, all driven by these insane growth projections. And, well, you can see the stress points starting to light up. The digital world is getting incredibly thirsty for energy, in a way our physical infrastructure was just never, ever designed to handle.
And this is where the timelines just completely collide. An AI data center, you can go from an idea on a whiteboard to a functioning building in maybe 12 to 18 months. But the massive new transmission lines needed to actually power it, we're talking 5 to 10 years. It gets bogged down by permits, reviews, and just the simple fact that you have to physically build it. See, AI is moving at the speed of finance, but the grid, that moves at the speed of physics, and those two clocks are not aligned at all.
So let's just try to wrap our heads around the sheer scale of this new power demand. This isn't just a little bump. It is a fundamental shift in how much energy we're talking about.
Just a few years ago, a data center was for a utility company, just another customer. But today, a single advanced AI cluster can consume the same amount of electricity as a mid-sized city. This isn't some marginal increase anymore. This is full-blown industrial expansion. And the power density, the amount of energy used per square foot, is just going through the roof.
And to put a number on that, Deloitte is reporting that some of the big players are planning data center campuses that will need up to 2,000 megawatts. That's 2 gigawatts for one campus.
And the biggest of these planned campuses? Get this, they could use enough power for 5 million homes. That is more than the largest nuclear power plants in the United States. It's just an almost unimaginable amount of concentrated, round-the-clock demand.
It's so easy to forget, isn't it? We talk about the cloud, we talk about these incredibly smart AI models, but behind all that abstraction are these massive, power-hungry, very real physical buildings. This is the hardware that is powering the software revolution.
Okay, so what happens when this city-sized thirst for power slams into a rigid, slow-moving system? Well, you get a bottleneck, a very, very long one.
Generating the power is really only step one. That energy has to actually get to the data centers. And that's where we hit the wall, transmission. There is a massive, multi-year backlog of projects all waiting in line just to connect to the grid. And on top of that, we've got shortages of critical hardware, like transformers. It's a system-wide delay. And we're not talking about minor delays here. As Google's head of energy and sustainability said, companies are literally being told it could take a decade or more just to get a connection. I mean, can you imagine trying to build the future of AI when you're on a 10-year waiting list for electricity? And yet you look at the financial markets, and they are pricing in this rapid, almost vertical growth for AI. But that assumes the power will just appear. When you actually chart the projected AI revenue against the flat, slow-moving reality of infrastructure capacity, you see this growing gap. And that gap, that represents a huge mispriced risk.
And hey, this isn't just a big tech problem. The cost for all these necessary grid upgrades is already getting passed down. In some areas with a lot of data center activity, people's home electricity bills are projected to go up by 16, even 18 bucks a month just to handle the strain.
This enormous pressure isn't just hitting us in the wallet. It's forcing a fundamental change in how the entire industry even thinks about power. The old way of doing things is breaking down.
So this pressure is forcing a radical shift. In the old model, power was just another predictable operating expense, like a monthly bill. But now, with the grid totally maxed out, it's becoming a massive upfront capital investment. Tech companies are now being asked to directly fund the construction of new power plants themselves.
And you're actually seeing industry leaders starting to acknowledge this new reality. Anthropic's CEO Dario Amodei put it really plainly. The companies that are driving this demand should be the ones paying for the infrastructure to support it. That's a huge shift in corporate responsibility when it comes to energy.
So what does this new world actually look like? When power becomes the main limiting factor, the entire game changes.
It completely redraws the map of strategic advantage. Suddenly, who is leading the AI race might have less to do with software and more to do with kilowatt hours.
Regions with abundant, ready-to-go power, places like Canada, the Nordics, or parts of the Middle East, they gain a huge advantage. Meanwhile, other, more constrained areas could hit a hard ceiling on their growth.
This is really the core tension in this whole story. It's this clash between the speed of finance and capital, which wants to move instantly, and the physical reality of infrastructure, which doesn't. And when one side dramatically outpaces the other, you get friction. And that friction changes everything.
So here is the key takeaway. AI innovation is not going to stop, but markets are pricing for growth without limits, and they might be ignoring the most important variable in the whole equation. It's the physical constraint of energy that will ultimately decide where this growth actually happens and where it stalls. The constraint is what reshapes the cycle.
And all of this leaves us with a final, and I think pretty provocative question. As we race into this new era, what is the true foundational resource we should be focused on? Will the future of AI be defined by the elegance of its code, or by the raw availability of its kilowatts?